and I'm going to be talking today about towards a virtual rainforest. So here we see a graphic image of a virtual rainforest. It's Pandora, if anyone hasn't recognised it. But what we're thinking about now is how we go about producing an actual simulation of a rainforest, how we create something that will allow us to look at how changes to a rainforest might affect everything that goes on within that rainforest, which is quite a bold ambition. So we all know why we need a virtual rainforest. We have a habitat that is experiencing very rapid changes of large magnitude, and also a habitat that is important economically and socially to people's livelihoods. And it's being exposed to the effects, as Rob has said, of climate change, of El Nino, of many, many different impacts occurring very quickly. It's also something that changes over very long time periods. You might have very abrupt changes to the trees if they're cut down, but the responses to those changes are going to take many decades to realise. So understanding what is going to happen isn't amenable to experiment. You can't actually go out there and do it in the field. You have to figure out a way to try and understand what those responses might be in a much shorter time frame. So the only way we can do this is to build something that allows us to make changes to a simulation and to see what might happen, what are the ranges of outcomes that might occur if we make a particular change. So what do we need to do in order to build a virtual rainforest? We need to figure out what processes need to be involved, what models we're going to use to represent those processes, what data we need in order to parameterize those models, to say where they start, how they change. And we need to think about what scales we're actually going to ask questions at. There's a limit to what we can simulate. So where do we draw the lines? What are the bits that we actually want to find out about, and which bits can we average away? And then we have to have a plan of how we're going to do it. So here on the left, on this image, we've got a nice photo of an actual rainforest. And we're not going to be able to get every detail of that. We're going to have to abstract it away to different components and think about which bits of this rainforest we want to simulate. The abiotic environment, so the rainfall, nutrient cycling, things like that. Biodiversity, which aspects of biodiversity do you want to capture? If we're interested in species identity, that's really hard. But if we're interested in energy flows, trophic flows, possibly things like stoichiometry, then those are more tractable. Which habitats do we want to simulate? And then which cycles do we want to include? Obviously we need biomass, water, energy, carbon, but then nitrogen, phosphorus, what other bits do we want to keep track of? What other cycles? Do we want to be able to look at spatial heterogeneity? Are we okay to look at something, an ecological response unit, a sort of homogeneous thing that we want to see how that responds to change? Or do we want to allow heterogeneity within that unit? It might be that bits of it are on a slope, bits of it are boggy, or maybe bits of it are completely different habitats, so we can look at things like edge effects. And then human interventions. There's a lot that we might want to do. Now, there is a lot of prior art in modelling different parts of the rainforest ecosystem, or ecosystems more generally. There are a lot of forest models out there, ranging from simple stand models through forest gap models, like Formind, where you have a patch with a certain number of trees in that have a certain structure in their canopy that leads to a light environment, that leads to seedling growth. A reasonable amount of complexity. More modern simulations are using a sort of more trait-based approach. So rather than having a sort of set allometry for a particular tree, there's a range of traits, distributions that a species might draw from in order to represent how that species grows. So there's a lot of complexity in here already. There are a lot of soil process models. This is a snapshot from the ECOS model. The Smiths up in Aberdeen have generated lots of other people. There are many kinds of soil models as well. And there's lots of components to this. You've got the inorganic soil matter, you've got dissolved organic carbons, you've got all of these different inputs and outputs, which are things that people at SAFE have been working on, where we have data that might be used to parameterize such a model. There are hydrological models. This is a complicated one, where we're looking at topography, where we're looking at the flow of water between different units in the simulation, allowing those to form into channels to look at what might happen in the aquatic environment, looking at drainage, maybe looking at transport, so sediment transport, or nutrient transport, or even runoff of pesticides. So we might have a very complicated hydrological model, and models to do this exist. The dynamic top model, I've been informed by hydrologists, is something like this, where it allows you to have an actual digital elevation model and model what happens when precipitation hits that surface. And then you have ecosystem models. So this is Odum's Silver Springs model of, this is a simple aquatic ecosystem, looking at all the different components of that. But then you have more complex, larger scale models, like the Mattingly model, which is a global ecosystem model, which in a sense has a more abstract view of the world because it's dealing with much more with, because it's working at a very large scale, it has to work with sort of abstractions of different things within it rather than going to a sort of more species by species approach. We have to figure out where we want to draw a line between those two extremes and what's going on within the ecosystem. And then, excuse the slightly grainy photograph, management models. So what types of management might we want to incorporate? What models of management? Are we going to incorporate logging? Are we going to incorporate processes like liana cutting? So what interventions, whether they're destructive or constructive, do we want to include into a model? So there is a lot of prior art out there. There's many things that exist that we can draw on. The problem that we have is that none of these are interlinked at the moment. So they might include one component, but not another component. And that makes doing an integrated simulation quite difficult. You can glue bits together, but you're always then trying to maintain those links between the different bits that you're gluing together. You might have a script that pipes the output of one model into another. It's not elegant, but it's not fast and it's brittle. So having a single cohesive system that allows you to incorporate all of these different modules in a single framework is something that will be incredibly valuable, potentially not just for a rainforest, but as a more general ecosystem model. So we have ideas of what models we might want to use, but then we have to think about what scales we might want to operate at. Although we might want to, we're never going to be able to track the fate of this individual termite. So we're going to have to draw lines somewhere, and we need as a community to decide where those lines are. We might, if we wanted to, be able to track the fate of individual trees. We might not need to, depends on what questions we're trying to ask. If we want to know about forest structure, if we want to know about different levels in the canopy height, the complexity of the canopy, the density of stems, things like that, then we might need to have a full model where we have individual trees in our simulation. If what we're interested in is the temperature at the ground level, microclimate, the amount of photosynthetic activity going on, then we might not need to simulate individual trees to do that. We might be able to abstract them. So deciding on what level of complexity we want to work at is important. And then we come to data. So why are we talking about a virtual rainforest? As Rob has been talking about, at SAFE we have a huge resource of data derived from very many different disciplines. We have people working on so many different aspects of rainforest, of the SAFE rainforest, that we have a unique opportunity to try and parameterize such a model using SAFE as a model system. And over the last couple of years, we've been working very hard at trying to mobilize the data coming out at SAFE. This is something that's been a problem for a long time. We have, as I've just said, we have very heterogeneous data. So trying to archive that data, make it available to people, make sure it's well annotated, that people can discover it, has been a thorny problem that we now think we have a solution to. It's not a perfect solution. It's not recording every last bit of metadata that anybody might conceivably want, but it's getting the metadata that will allow people to discover data, find what's out there at SAFE, and then make their own evaluation of whether it's suitable for their purposes. So over the last year, we've started to see data coming into our Zenodo repository. At the moment, we've got nearly 70 data sets that are archived up there, and we're just starting a big push with some money that's part of, so I'll talk a little bit about the Virtual Rainforest Workshop in a second, but as part of that, we're hiring some people in order to help us do a big push to get as much of the existing data up there as possible and to keep that ball rolling and exposing as much of the safe data as possible. So we have the processes we're interested in. We have the models that we might use as templates. We have the data. How do we make it happen? That's you guys. So over this week, we started this yesterday. We had a workshop yesterday starting to talk about how we might think about building the virtual rainforest. And many of the people who are at that workshop are among you today. And one of the things that we're very keen to get out of the next few days is figuring out what data we have, how people might want to use a virtual rainforest, and then start to think about where do we draw the lines, what are we going to include, what can we include, what data do we need to get in order to make it work. So people will approach you and talk to you about data and processes in virtual rainforests. Please engage with us. We want to build this thing, and we can't come up with a blueprint until we've started to answer these basic questions. So thank you. If anyone has any questions, please ask them. Otherwise, we will be around and coming to find you. Thanks very much.